So another way that you can prove triangles are congruent is through SAS, which is side, angle, side. So it's similar to angle, side, angle. This one has got two sides with the angle in between. Two sides and the included angle. That's why it's two sides and the angles in between. It's included between the two. So for example A here, we have 20 centimeters and 20 centimeters, 19 centimeters, 19 centimeters. So we have two congruent sides. Is the angle between them also congruent? So we've got a 43 degree and a 45 degree. The angle is different, so these are not congruent. The angle between the two sides also needs to be congruent. Similar over here, 46 is going to match with the 46. The 74 matches with the 74. And the angle between them has to be the same also. 37 degrees, 37 degrees. Yes, they are congruent. We have the two sides with the angle in between. They are congruent because the two sides, JK, is congruent to MN. Is it J? You got to start with J. Nope, MN, yeah. You have to name it in order. So since we started with J, which is where the angle is, we got to start with M, where the angle is. Then angle, the angle in between was angle J, is congruent to angle M. And then the other side, JL, is congruent to MP. And remember, you can always talk about the rotation that it would take to get it to match up so that they are in the same orientation, and it might be easier to tell what letter goes with what letter in that case. So, similar question, determine if they are congruent, explain your reasoning. So we've got a 2.5 side and a 2.5 side, those are congruent. We have a 1.7 side and a 1.7 side, those are congruent. So we have two sides, the angle in between has the marking, two sides, the angle in between has the marking. This would be a reflection to get them to match up. So yes, they are congruent because side ED is congruent to side HG. Angle D is congruent to angle G. And then side DF is congruent to side GJ. When you're naming, you do need to name the corresponding parts together. So D had to match up with G. Anytime we wrote D, we had to write G first. So now we're going to write a proof using side angle side. This actually comes from a real life problem, the triangle from a house window. So we know that BD is the perpendicular bisector of AC. BD is a perpendicular bisector of AC. That's always the first thing you write is the given. BD is the perpendicular bisector of AC. That was given. So since it's a perpendicular bisector, that means they are perpendicular. And it's a bisector, which means cuts it in half. So if it cuts AC in half, it creates two congruent pieces. AD is congruent to CD. Specifically, that's the bisector part of perpendicular bisector. Then BD is also perpendicular to AC. That's specifically the perpendicular part, which means it makes two right angles. And those two right angles are congruent. BDA is a right angle, and BDC is a right angle, and all right angles are congruent. So we need one more piece of information. Right now we've got a side and an angle. Looking at the picture, we can see that there is a side that they share. They share BD. BD is congruent to BD. Everything is congruent to itself. That's the reflexive property. So now we've got two sides and the angle in between. So the triangles will be congruent. Triangle BDA congruent to triangle BDC. And that was because we have the two sides and the included angle. That's side, angle, side. We've been doing a lot of work with two-column proofs. This is a paragraph proof. There's just a few blanks that we have to fill in though. So just like a two-column proof, you would start by writing what was given. So it is given that CD bisects AE and AE bisects CD. So then you'd go through with what that means. If CD bisects AE, AE is cut in half, we get two congruent pieces. AB is congruent to EB. Should be a little congruent symbol there. Oh, they do the congruent symbol later. Also, since AE bisects CD, it cuts CD into two congruent pieces, right there and there. So that means that CB is equal to DB, which means that they are congruent. Also, we have an angle ABC, ABC. That will be congruent to this angle right here, which is EBD. Because they are vertical angles. So now we have two sides and the included angle are congruent to two sides and the included angle, triangle EBD. So the triangles are congruent by side, angle, side. Two sides and the included angle. So the other type of proof we're going to look at is right here. It's a flow proof. So just like any other proof, you start with the givens. We're given AB is congruent to AD. We were also given angle 1 is congruent to angle 2. And then you get those marked in the triangles. So then from the picture, we can get something else. So looking at the picture, we have both triangles have this side right here, AC. So AC is congruent to AC. And the reason for that, that's called the reflexive property. And then looking at our diagram, we can see we've got two sides and the included angle. So the triangles will be congruent now. That's enough. Triangle BAC is congruent to triangle DAC. Two sides, the included angle, side, angle, side.